In this video, we're going to be talking about describing variability in a data set. Well, why is the study of variability important? Well, there's variability in virtually everything. For example, take this can of soda. Does this can of soda have exactly 12 ounces? And can you be sure that the next can of soda that you open has exactly 12 ounces? No, you can't. Variability allows us to distinguish between usual and unusual values. Reporting only a measure of center doesn't provide a complete picture of the distribution. For example, here we see 3 data sets. Notice that they all have the same mean and median at 45, but they have very different amounts of variability. The simplest numeric measure of variability is range. Range is taking the largest observation and then subtracting the smallest observation from it. Here, the first 2 data sets have a range of 50. You take 70 minus 20. But the third data set has a much smaller range of 10. It's important to note that when you are describing the range, you are giving a single number. So you're saying the range is 50 or the range is 10. You are not giving the ranges from 70 to 20. Now, another measure of variability in a data set uses the deviations from the mean. So that's where we take our sample and we subtract that from our mean. Now, think back to the video where we had our fish, our sample of 6 fish that we had caught from the lake. They were the following lengths: 3 inches, 4 inches, 5 inches, 6 inches, 8 inches, and 10 inches. And the mean length was 6. Now recall that we calculated the deviations from the mean. Do you remember what the sum of these deviations were? That's right, they were 0. We can find an average, or can we find an average deviation? What can we do to the deviations so that we could find an average? Well, the estimated average of the deviation squared is what we call the variance. It's represented by the equation s squared equals the sum of the deviations squared divided by n minus 1. Now we do n minus 1, it's called the degree of freedom. Now this is our sample variance, so if we were trying to find our population variance, it would be denoted by a sigma squared. Now suppose that everyone in the class caught a sample of 6 fish from the lake. Would each of our samples contain the same fish? Would our mean lengths be the same? The samples would also have different ranges. When we calculate sample variance, we use degrees of freedom, which is our n minus 1, in the denominator instead of n, because it tends to produce better estimates. Now, you could argue that, not really argue, but basically if we go back to our fish and we were to add them together and we were to add 5 of the 6 deviations, we would know that in order to get a 0 for the sum, that 6th deviation has to be the sum of the other 5. And so that kind of tells us that 6th number, that 6th sample, it's not really independent. And so therefore, we say that the n deviations actually only contains n minus 1 independent pieces of information about variability. And so statisticians usually express this by saying that like s squared and s are based on n minus 1 degrees of freedom. But we're going to talk a little bit more about this in some future chapters as well. Now again, remember the fish from our lake, right? Our sample of 6. Let's find the variance of each of the lengths of fishes. So we found those for our deviations, so now we're going to square those. So finding the average of the deviations would always equal a 0. So if we find the square of the deviations first, then we get 9, 4, 1, 0, 4, and 16. And when we sum those together, we're going to get the value 34. We're going to take that and divide it by 5, because remember, we have n minus 1, because that accounts for our degrees of freedom. So we have 5 degrees of freedom here. So we'll divide it by 5. We'll find that our variance is 6.8. Now the square root of variance is what we call standard deviation. A typical deviation from the mean is what we call the standard deviation. That's what that is. So here we have our variance squared is 6.8 inches squared. So our S, or our standard deviation for our sample, is 2.608 inches. The fish in our sample deviate from the mean of 6 by an average of 2.608 inches. So we're going to the calculation of standard deviation of a sample is this equation. S equals the square root of the sum of the variance squared, or sorry, the variance rather, divided by n minus 1, which is our degrees of freedom. Now, this is for our sample deviation. If we wanted to find our population standard deviation, we would use a sigma. Now, the most commonly used measures of center and variability are the mean and the standard deviation, respectively. Another measure of variability is what we call the interquartile range, or the IQR, and it is the range of the middle half of the data. To find it, you'll first need to be able to find your lower quartile, which is referred to as Q sub 1, and it is the median of the lower half of the data. You'll also need to know what the upper quartile, or our Q sub 3, is, which is the median of the upper half of the data. The IQR is found by subtracting the Q sub 3 minus our Q sub 1. So it's found by subtracting the upper quartile and the lower quartile. So what advantage does using the IQR have? Well, the IQR is resistant to extreme values. Let's do a quick example. So here we have the Chronicles of Higher Education published the accompanying data on the percentage of the population with a bachelor's or a higher degree in 2007 for each of the 50 states and the District of Columbia. And here's the following data. So we're going to try and find the interquartile range for this set of data. So here's our data, and the first thing that we want to do is we want to put the data in order to find the median. So I'm going to give you a moment. Go ahead and push pause, put your data in order, and when you're done, push play, and we'll go from there. So here's our data in order. We're now ready to find our median. So go ahead and push pause, find your median, and then push play, and let's see if you were right. Our median is 26. So we're now going to find the lower quartile range by finding the median of the lower half. So go ahead and push pause, and when you found the lower quartile, then push play and let's see if you're right. Something to note here is that our median of 26 should not be used when finding the lower quartile range, not the pink 26. So it's okay to use the blue one, but not that pink 26. Did you get a lower quartile range of 24? Now find the upper quartile by finding the median of the upper half of data. So again, remember that our pink 26 is not to be used when we're finding that upper quartile median. Did you get an upper quartile range of 30? So now, in order to find our IQR, we're going to take our upper quartile range and subtract our lower quartile range from it. So here we have our IQR equals 30 minus 24, which equals 6. In our next video, we're going to go through how the IQR and the standard deviation can help us in determining if our data set has outliers.